Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about math and science. Yay! This is a physics class where it's primarily designed for homeschoolers, but if you like the way I explain things, please join us. In the homeschool class, we're going through this physics book. If you're interested in joining the homeschool class, the ISBN number and everything is in the introduction. Go find the introduction physics class, or the very first one I posted. That'll be the one. Or maybe the second one will be the one where I tell you the book number. It's an older public school book, so therefore it's cheaper. And the physics is all still the same, so you can get your book for cheap and work through it with us. Now, most of my physics videos are two parts. In the first part, we're going to talk about the concepts, and the second part, we're going to do the math. And for this, in the math, I'll be zoomed up on the problem and on my calculator. You won't get to see me, but the math is going to be the longer one on this one, and a lot of them, because this one, I'm going to quickly explain the concepts, but then you got to come back and see the math. Now, depending on the physics class you're taking, physics can be taught at different levels. It can be taught without much math at all, where it's just the concepts. And in that case, you might not even need to go see that other video. But this class that we're doing is this homeschool class, it's really a college prep, almost honors level physics. So we do all the math. So you need to, if you need the math, we'll be going through, and I like these problems. There's certain things I like in science better than others, and I really like these problems that we're about to talk about. All right, so what is this chapter? It is vectors. So in physics, there are certain quantities that have magnitude and direction, and others just have magnitude. Now, what do I mean by that? Well, like if I tell you a temperature that it's 30 degrees Fahrenheit. We'll go English even and use that English unit. It doesn't have a direction. It's in all directions. Everywhere you go, it's 30 degrees Fahrenheit. But other things have a direction. Like, for example, I could be traveling along the road, and I am traveling 55 miles an hour northeast. If I was just traveling 55 miles an hour, it wouldn't have a direction, and it would be speed. But when I add northeast to it, it's velocity, and it's a vector quantity. Things that don't have a direction are called scalar. Things that do are called vector. Now, vector quantities are ones with direction, and it's a lot of times a force that's applied in a direction. We'll talk about that more in a second. But there are different ways to solve these problems. But first of all, how are vectors represented? How are vector quantities? They're represented with arrows. The arrow direction and the arrowhead shows the direction of the force, or whatever it is, and the arrow shaft, the tail of it, however long it is to scale, showing the magnitude, the force, the amount. So that's the first thing. The second idea about it is they can be solved. These problems can actually be solved graphically. And when you do it, you draw it on graph paper, you make a scale for the graph paper, and then you add the vectors. They are always added head to tail. So if I have one going this way and another one, I would line it up. And that means I might have to move it from where it was originally, but it's okay. As long as I keep the same length in the same direction, I can add them up. And then you can draw a line from the original tail to the final head, and you can find a resultant. Like, say if it's forces, you could find out what the final force is when these are all added together and what direction it's in and how strong it is. So I used to teach a physics class a long time ago, decades ago, and we won't talk about how many, where we would have math labs in the physics class and we would do one where we would graphically add vectors and solve them. And it was fun and interesting. And if we were face to face, I would make you do it too. Well, I'd pass out the graph paper and the protractors and rulers, and we'd do it. And the compasses, we'd get all those geometry tools out and add these vectors up. Okay, so that's one idea. The other idea is you can have, so we talked about vector addition. I'm making sure I'm hitting all the conceptual points in the book. I'm looking over there. What was that one? Okay, this is the next part of it. It's this right here. See, I pre-drew this. Okay. Say I have a force going this way. That force can be broken down into its x component and its y component, and they are independent of each other. So what does that mean? It just means that you can do the math easier. It makes it better because you can figure out the x and it has nothing to do with the y, and you can figure that out, and you can break that force down into its components, and that's useful. We're going to be doing some problems, and this was another thing I wanted to tell you. I had this wrong idea when I was in high school, and now that I've taught high school for decades, we won't talk about how many, that I realized that I was under a misconception, and this is the misconception. Physics problems are word problems, so this would apply to word problems in math and in physics, but I had the idea that there was just an infinite amount of problems out there that my teacher could pull from to torment me with. But it turns out there's really not that many problems out there. We changed the numbers, but there are certain classic problems that we do. We like to find out how tall a tree is. We like to find out what happens when a boat tries to cross a river. We like to buy a bunch of watermelon. We like to join video membership clubs. I know you laugh, but because the books are written so long before they're actually published and gotten in the hands of the school children, that they're always out of date. So there's the word problems in algebra books are always funny. They're a non-ending sense of humor. Either people's buying ridiculous amounts of watermelons or doing ridiculous math that no one would ever do, or else they're doing something that technology is obsolete already. So there's always the algebra problem about you want to join the video membership club. How many are you going to have to how many times are you going to have to rent before it's worth your money? And it would be better to just pay the upcharge. So there are just certain problems that you see over and over and over again. And it's the same way with these vectors. We are going to hang a sign, or it could be a kid hanging off something, but we're going to have something hung by two things. You're always going to have that problem where a thing is hung with two things in the vector chapter, no matter what book you go to. You're going to have where there's two forces and it makes a resultant force. And how I do this problem with my students, if we were face to face, is I would say that here is a pin, and I'm going to pull the pin straight toward me, and the student sitting right here would put their hand on it and pull it straight toward them, and let's see which way it goes. Well, it doesn't go straight to me and it doesn't go straight to them. It goes somewhere in the middle. So we have an X component, me, notice that it's less long, the Y component, the student, and then we can add them head to tail, draw the line, and get the resultant, what it really does, which is go somewhere in between. The resultant is what it really does. So we could break it into its X and Y components. So you're going to have that problem where you break things into the X and Y component and you get the resultant. The other thing you always have is you are pushing something up a ramp. It could be a chest, it could be whatever, a box, a refrigerator. You're going to push a box up a ramp in one of these problems, and you're going to have the weight going down. You're going to have an angle. Remember, angles are theta. They're the unknown angles are not x. They're the Greek letter theta, a circle with a line through it. You're going to have friction on this. I don't know if we've talked about friction yet. It might not have friction at this point. It might have the friction later if we haven't gotten to it yet. I can't remember because I teach physical science, which is also a physics class, to homeschoolers, and I teach physical science to public school kids. So it's hard to remember who I've taught what. I also teach chemistry to public school kids, and that I can keep straight. I haven't told you about any of the chemicals I told them about. All right, so I'm going to show you in the other video how to do all of these problems step by step. But once you learn the basic problem, then you memorize how to do it and you practice it. Math is a competitive sport where you have to train for it, just like any other sport. And it's one you can win in. You can make good grades, and that can lead to a career that gives you a lot of money. So the most profitable majors in science are the STEM majors. They're the math and science and engineering majors. So it's something you can win at. So anyway, and then the other part of this conceptually is sometimes we have to figure out the angle, or we could have to figure out sides. And to do that, we're going to use trig. We're going to use trigonometry. So I'm going to go over teaching you in the video some basic trig, and you're going to use it in this class. Now, what if you haven't had any trig yet? Don't worry, I'll teach it to you. I learned trig in physics class in high school before they got to it in math. And many of my students have learned it in physics class before they got to it in math. I also teach geometry. I teach trig in geometry, and I teach trig in algebra 2. And both of those curriculums don't get to it till the spring. This is the fall, and we're already using it in physics. So unless you've already had algebra 2, geometry or algebra 2, then there's a chance you have not had trig, but that's okay. In fact, this was the funny thing about when I learned trig in high school. There was this one little group of us that go around high school together that we were all in the gifted program. We were the smart, geeky kids. Is that surprising? Probably not. That I was a geek? No, not surprising. But we had the same classes all day together, all day, every day, 4 years. I mean, it probably started in the 6th grade when this group of us started getting tracked together. So we knew each other really well. We weren't necessarily friends, but we had spent all this time together for years, so we knew each other real well. And we were in physics class, and my physics teacher, Mr. Sheffield, started teaching this, and he taught it assuming that we knew trig. And he was saying, you know, you take the cosine of this and then do the inverse sine here. And we were all just like, you know, we were like too scared to say anything. Well, he got called out of the room for like a phone call or something. He had to go to the office, so he left. And we all turned to each other and said, do you know what he's talking about? No. Do you know what he's talking about? No. Well, one kid, Doug, knew what he was talking about, and he said he's doing trig. And we're like, show us. And he started trying to explain it. We're like, no, go to the board. So Doug went to the board, and he taught us trig. So another kid did. Then Mr. Sheffield came back, and we were like ready to go. We knew the basics, and we were going to learn more later, but we knew enough to do that physics lesson, so that was funny. And later he ran for office in Smyrna, so you could look up the guy who named Doug. I can't remember his last name. I'll think of it. Anyway, he's a politician in Smyrna, Georgia now. He's a Democrat, and you can look him up, and you can say, oh, that's the person who taught Miss Lisa some trig. She wasn't even a teacher who taught me, so I'll teach you this time. And if you want to learn more, I'm releasing slowly each week the algebra 2 and geometry. So wait till the spring, and and those videos will be up too. I'm not releasing them yet. I'm just doing it because kids are taking these classes. I don't want them to be confused. But so what I do is I release each week the videos they need for that week. So even if I'm recording it ahead, I leave it unlisted until it's time. Now, eventually people are just going to have to figure it out themselves, because I'm going to leave it up here even next year. But for this year, I'm going to, release it slowly. Okay. All right. Let's see if there's any other concepts. So we care about boats crossing streams. We care about airplanes going across wind currents. All of these are the problems. Oh, and we pull wagons and sleds. We like to pull something and use the trig to figure out the force and the angle and the direction. So there's only a certain number of problems. 2 kids picking up a log. That's one of the ones. Hanging a sign, that's one. My other physics book I teach out of, Conceptual Physics, is a kid hanging on a jungle gym. But they're really all the same problem. So once you know how to do it, you know how to do it. Yep, we're going to push a trunk up a ramp. And, looks like maybe going to go down. Oh, it does talk about friction. So we are going to do some friction problems too. All right, so those are the concepts I can teach you without actually showing you the math. And I want to show you the math up close, where you can see my calculator, you can see the problem, and you can see exactly what I'm doing. So I'm going to turn the camera around, and you won't see me. You'll just see that, and we're going to go through a bunch of problems. But they're good, they're fun, and they're classic problems. Once you know them, you will do these same exact problems when you get to college physics. no different. They're classic problems. So I'd like you to like, share, and subscribe because I have a goal. I want 1,000 subscribers and you could help me out. Share it with your homeschool groups. It's a free physics class and easy to take. You just get the book, follow along, watch the videos, and I assign you problems where the answers are in the book so you can check your work. And there's also a Facebook group that has tests and answers on it. I don't know if that'll be there forever, so if you're watching this video years in advance, you might have to order the teacher's edition to get the answers to the test or get the test bank with the answers or a solutions manual. But they're all out there and they're cheap because it's an old edition. So anyway, like, share, subscribe. I'm Miss Lisa. Science is great.